Okay, I have a feeling this is going to be a long video, but I'm not going to see you for a few days, so maybe you can watch it over a couple days, okay? So, again, we want to make connections between the graph of f and the graph of the derivative for both polynomial and trig functions. So, again, we want to start making the connections if we know something about a derivative, what we know about the function, or the other way around. So, it says if the derivative is equal to 0, think about what that means. If the derivative is equal to 0, that means the slope of the tangent line 0. We know that's a horizontal line, right? So then that means that the derivative is 0, then f of x has a horizontal tangent line. It means that it may be a relative max or min. All right? Could be a relative max or min. Not guaranteed, but it could be. What do I know if the derivative is greater than 0? If the derivative is greater than 0, that means the derivative's positive, so that means the function is increasing. Not necessarily positive, but it's increasing. If the derivative is less than 0, then the function is decreasing. And if the derivative changes from a positive to a negative, right? So the changes from a positive slope to a negative slope, which means the graph changes from increasing to decreasing, right? From increasing to decreasing, then that means the function has a relative maximum. Then f of x has a relative maximum. And if the derivative changes from negative to positive, that means it's changing from decreasing to increasing. That means the function has a relative minimum. So look at this next one. It says, look at this graph and think about if you could make a possible graph of the derivative. Now this is going to be a little sketchy, but think about what we know for sure. This graph I can see is increasing, decreasing, increasing, decreasing. So at these turning points, what do I know about my derivative, right? That's going to be where the derivative is equal to 0, right? Those are horizontal tangents. So that means that f prime of x equals 0 at those points. So 1, 2, 3, 4. At negative 4, my derivative is going to have a 0. At positive 1, my derivative is going to have a 0. And at 1, 2, 3, 4, 5, my derivative is going to have a 0. Now, in between there is going to be a little bit sketchy because of what's happening. But what do I know? This is increasing, right? So this means that my derivative is greater than 0 here. And then when it's decreasing, that means my derivative is less than 0, greater than 0, less than 0. That's really messy. You probably don't want to write that. But do you see what I'm saying? Like, okay, maybe this will be better. My derivative would be positive here, negative, positive, negative. So above here is going to be positive. It's going up forever, right? I don't know exactly how, but I know it's going to go up like this. And I know between these 2 points, it's decreasing, so it's negative, and they got to connect. This is a polynomial, so this is a polynomial, so I know it's going to be like a smooth curve. I don't really know how far it's going to go down, but I'm going to just kind of wing it. That's why it says a possible graph. What do I know in between these 2 points? Well, it's positive again, so it's going to be increasing again. Again, I don't know how far that's going to go up. I'm just kind of winging it. And then it goes back negative, so it's going to be decreasing again. Is that the perfect derivative? Probably not, but it's a pretty good sketch of knowing where the derivative is positive and negative and where the zeros are. Okay? Also think about this. This is an even function. It has 3 turning points, so its derivative is going to have 1 less than that. Also, its derivative is going to be an odd function if this one's even. So thinking about what we know about polynomial functions. Okay? Okay, this next page has a lot of stuff on it, but there's just a lot of questions looking at this. So we're going to work vertically here. So the first one here says, pictured below is the graph of the function f of x. Answer the questions that follow about f prime of x. So really important to notice that this is the original function, kind of like the one on the previous page. It says approximate the derivative of f prime of 4. And we've done this already a few times. Approximate the derivative means use points around it. So of positive 4, so 1, 2, 3, 4, that would be right here. So if I want to use points around it, I'm going to use the points that I can see on the graph really easily, like this point and this point. And again, think about what we're doing. If we connect those two, that's pretty close to the tangent line, right? And so that's why we're approximating using points around it. So the points around it that I can see are 3, negative 1, and 5, 4. Do you agree with that? I feel like these boxes need to be bigger. So I'm going to show my work by saying f prime of 4 approximately equals, using the slope of the secant line, 4 minus negative 1 over 5 minus 3, or that would be a slope of 5 halves, okay? Or 2.5 if you love decimals. Look at the next one. It says, at what value or values of x is the derivative equal to 0? Justify your answer. So, looking at the graph, we can think about this, right? Those horizontal tangents are going to be at those turning points of the graph. So, I think there's 3 at x equals 1 to negative 4, x equals 1, and x equals 5. What's my justification? There's a couple ways we could say it. I could say because that's where the graph changes from positive to negative, or negative to positive, or sorry, increasing to decreasing. I could say because there's a horizontal tangent there. I don't know, however you want to say it. I'm going to say because f of x has a horizontal tangent at these points. It says on what open intervals, so notice they don't want us to include endpoints, is the derivative less than 0? Justify your answer. Sometimes you can do the justification first. I know f prime of x is less than 0 when what? When f of x is decreasing. So that would be where? Where is it decreasing? It's decreasing from here to here. So that would be from negative 4 to 1. And it's decreasing from 5 to infinity. Or you can give the answer and then give your justification. Because f of x is decreasing. On what open intervals is the derivative greater than 0? Justify your answer. Again, I'm going to say I know f prime of x is greater than 0 when f of x is increasing. So that would be on the intervals everything else, right? Negative infinity to negative 4, and from from 1 to 5. Look at the next one. I'm going to go back up to my graph now. At what values of x does the graph of the derivative go from being below the x-axis to above the x-axis? Justify your answer. So think about this. Where does the derivative change sign? So from going from negative to a positive. Well, that's going to be where the graph goes from decreasing to increasing. So where does the graph go from decreasing to increasing? I think right here, right? It's decreasing and then it switches to increasing at that relative minimum. So this is going to happen when f of x changes from decreasing to increasing, which is at the x value, x equals 1. At what value of x does the graph of the derivative go from being above the x-axis, that's positive, to below the x-axis, that's negative? So that's going from increasing to decreasing. So that's going to happen when f of x changes from increasing to decreasing, which I think is at 2 points, right, at the relative maxes from increasing to decreasing. So that's going to be at both -4 and +5. Okay, so again, just kind of getting used to that talk with the derivative. So look at this one. It says, picture below is the graph of f prime of x on the interval -3 to 4. Answer the following questions about f of x. On what open intervals is the graph increasing? Justify your answer. So now notice that this is the graph of the derivative, okay? So very big idea is that if they give you the function, what you're looking at, versus if they give you the derivative. So they gave me the derivative now, and they're asking me where the function is increasing. Well, f of x is increasing when what? When f prime of x is greater than 0, or when it's above the x-axis, which means the only place this graph has a positive derivative is right here. So only on the interval -3 to -2. And again, it says open interval, so we don't have to worry about whether we're including the endpoints or not. On what open intervals is the graph of f of x decreasing? Justify your answer. Again, f of x is decreasing when f prime of x is less than 0. So everywhere it's below the x-axis, when it's a negative derivative, that's going to be everywhere else, right? So that's going to be from -2 to 4. Oh, wait a minute, I'm wrong. Why am I wrong? I really want to say -2 to 4. My book answer says -2 to 2 and then 2 to 4. Why isn't 2 included? Because at 2 itself, the derivative equals 0, right? So be really careful about that. I about messed that up. Look at the next one. That's kind of what led me to know I was wrong. It says, at what values of x does the graph have a horizontal tangent? F of x has a horizontal tangent when what? When f prime of x is equal to 0. And that's at 2 places. At both positive and -2 is where my derivative equals 0, and then it changes from positive to negative. But it's not guaranteed to be a max or min, and here's the reason why. Okay, so look at the next one. It says, at what values of x does the graph of f of x have a relative maximum? Justify your answer. And I'm guessing the next one says, where does it have a relative minimum? Justify your answer. Well, where the derivative equals 0 is where our options are. So look at this one. At -2, what happens at -2? Well, it went from being above the x-axis to below the x-axis. So the values went from positive to negative. So that means the function's going from increasing to decreasing. So I would say that the graph has a f of x has a relative max at x equals -2 because f prime of x changes from positive to negative, indicating that the graph of f changes from increasing to decreasing. I'm not going to write that part, right? Because the f prime changes from positive to negative. But what about the relative minimum? The only other option for that to happen is here at +2. But look what happens at +2. It's negative on both sides. It's below the x-axis on both sides, which is why just because the derivative equals 0 doesn't guarantee that it's a max or min. You have to look for the change in sign from positive to negative or negative to positive. And so the answer here is f of x doesn't have, right? Doesn't have a relative min because f prime of x doesn't change from negative to positive, which is what we would need to have. We need to have it changing from decreasing to increasing. And then what about the last one here? It says, what is the slope of the normal line to the graph of f of x at x equals 4? Justify your reasoning. So if we're talking about the normal line, first of all, we need to think about what f prime of 4 is. So let's go up here. This is the graph of the derivative, right? So at 4, f prime of 4 is that y value, which is negative 2. This is the graph of the derivative. So we're not looking at the slope of this graph. This is the derivative graph. So because f prime of 4 equals negative 2, that's the slope of the tangent line, right? That's the definition of the derivative. So the slope of the normal line is just the opposite reciprocal of that. Because they're perpendicular. Would be what? Positive 1/2. Where's my time at? 16 minutes. Okay, I better stop. We'll start this in class.